for your notebook for the 6 weeks. We do have a work day tomorrow, so please do not like totally wig out when I show you how to work these problems that you're like, what the heck? Because we do have a work day tomorrow. At least thankfully, the hard part with empirical to molecular formulas was taken out. We were told that all you guys have to do is to be able to figure out, like identify what's the difference between them instead of actually calculating the formula, which is really not that hard, but y'all are gonna say it's impossible. So that part was taken out. You just have to be able to identify, is it empirical or is it molecular today? And then I have to teach you how to be able to do percent composition. For the opener today, how do we, or what do we use? But what do we use to calculate molar mass? Is it not? Hold on. I probably did not even open the entire frickin' thing. I bet you I didn't. I didn't. Hold on. I'm publishing it right now. I got it. Okay, refresh it. It should work now. I say that, and you watch. You didn't open a text box. That's what happens when I have to run home on the date today is the 8th. Do you have a tardy pass? Do you need to go? You need to go get a tardy pass. I was in here the entire time. I didn't hear, can I go to the bathroom?
You don't think so?
Well, I do. All right, let me double check and make sure that the opener is actually it. Then, you had too many tardies? Okay, everything does look like it's open. Okay. All right, so anyways, back to the open. Tardy pass. Tardy pass also. No, tardy pass. Oh, goodness gracious. All right. I don't know if anybody did not. Is there anybody else that needs the notes page from up here?
Is this it, or is this worksheet right here too?
Both of them.
And this one
Yep.
right here too?
No, that's her space.
Okay.
No. What? That's a good question. Let me see.
I don't know. I think he's got food. I don't know.
Not right now, no.
Okay.
All right, now I'll check.
Like literally everything about him. Like I was talking about my problems. Like I would just start talking to him, talking about my problems, but like then he'll be like start talking about his problems, just like push me like he's like complaining like he's like well, you're not being very supportive person right now. I'm going to the hospital to see if I have to have surgery. Like, okay. You did everything about him. I was talking about me, but you did everything about him. Everyone has problems.
Okay. All right. Let's pull this back into chemistry real quick. All right. So, what is it that we use to calculate Conway? What is it that we use tonight? What is it that we use to calculate molar mass? What do we use to figure out how many grams are in a mole of something?
Isn't that
What?
whatever it's called, like the it's conversion rates. What's it called?
The periodic table.
Oh,
For molar mass, you have to look at the periodic table. You have to multiply how many of each element. Mask up, please. Write in. How many of each times its mass off the periodic table, 2 numbers after the decimal. So how do you know when to use molar mass? What unit do you see in order to be able to calculate molar mass? Why do you know to use the periodic table? You're going from moles to what?
Grams.
Grams. There we go. Mass, grams. Representative particles have a different number that's associated with them. What numerical value is associated with the molecule, the formula unit, or possibly the atom? What number goes there? The representative particle. What number goes with that? Either a molecule, a formula unit, or an atom. You don't know. You guys just had a test grade over this. You were supposed to create a what? Okay, but what number went with the mole? 6.02 times 10 to the 23rd. That's called Avogadro's number. Now, I noticed in our 8th period class that there was a flow chart that we had online that may help you be able to figure out what to use when. And if this does help you, I have some printed out. I've also put it into the previous week's module. There's this flow chart that goes between moles and then other things, whether they be moles to grams using a periodic table, moles to particles using Avogadro's number. The one that we have not done yet, moles to liters using 22.4, or if you're in a particle, you could possibly go smaller into atoms if you have a compound and not an element. If this helps you, I will give you a hard copy of it at the end of the class. Now, my numbers are going to be slightly off of everybody else. I'm actually one section, one numerical value ahead. I don't know how I managed to do that, but I did. But numerically for us, this is number 37. This is the last one for this, in this 6 weeks for your test grade. We're going to do percent composition second. We're going to do what now is the easier of the two, which is empirical and molecular formulas. Like I said, they've changed the teaks of chemistry, and instead of me actually giving you specific value amounts and having you calculate the formula, now all you have to do is be able to identify the difference between the two. Makes it a lot easier on your point. An empirical formula is a lowest whole number ratio. Basically, all that means is if you can reduce it, reduce it. That's all it means. A molecular formula, on the other hand, is the exact number of all of the elements that are necessary to make the compound, which means that you don't reduce it. They can be the same thing. So something like methane, which is CH4, you've got one carbon, you've got 4 hydrogens, it's already reduced. You can't get smaller than one. You just can't, not when you come to simplifying things. The samples I gave you on here, hydrogen peroxide, that stuff in the brown bottle that you put on a cut that bubbles up and sometimes stings and sometimes doesn't, its formula is H2O2. That is its molecular formula. 2 hydrogens for every 2 oxygens. Its empirical formula is just HO. It's just reduced. So what would have taken me probably 3 days to teach you has now been pushed down to a fraction of that time. The non-reduced whole number ratio is a molecular formula. The simplified version is called an empirical formula. And yes, sometimes they're the same thing. Somebody said it was Jimmy on the meet, and I did not see him, so let me double check on him. Stop eating in here. Out of the corner of my eye, stop. I see Lexi, Declan, Reagan, and Veronica. Veronica, Declan, Lucas, Sahara, Sebastian. I know a lot more people were quarantined that I've not seen come through the Caitlin's here. Tatiana's not that I haven't seen come through the system. Reagan, Skepler, Kyle, Jimmy. No, I do not see. Somebody just emailed me. Sweet. Robert, no. Tatiana, no. Oh no, Valerie is here. I almost marked you out, Valerie. I'll come back and check it in just a second. All right, so this is, like I said, what would have normally taken is probably 2 to 3 days worth to do. This is the only difference. Now, we have 3 different compounds. These are all hydrocarbons. These are the molecular formulas. These are the full value amounts. Molecular is not reduced. So sugar, or glucose, actually, this one on the left, what can you divide? You've got C6H12O6. What can you divide them all by? You can divide all these numbers by what? Go as high as you can. 6. So C6H12O6 would be CH2O. That's seriously all you guys are going to be required to have to be able to do with molecular and empirical formulas. It's like all you do is reduce it. That's all you do is reduce it. You simplify it. That's all you do. Exactly. All of these numbers are divisible by 6. 6 divided by 6 is 1. We don't write ones. 12 divided by 6 is 2, and 6 divided by 6 is 1. We just don't write ones. Okay, so then the one on the right, they're all divisible by what? 2. 8 divided by 2 is 4. 12 divided by 2 is 6, and 2 divided by 2 is 1. We just don't write ones. This can be way harder than what it has to be, but they cut that part out with the teeth. All you guys are going to be responsible to be able to do is to identify the difference between an empirical, which is the reduced version, versus a molecular, which is the non-reduced version. The one on the right, what are they all divided? Got 2. So that's going to be a 4, a 5, we do not write a 1, and then a 2. As far as this is concerned, yes. Percent composition is not quite as simple, but empirical and molecular is really this easy. Sometimes you can't reduce them, such as the case as methane, which is CH4. It's already in its simplified version. Like you can't reduce it. Or phosphorus pentachloride. You can't make it any smaller than that. If you've got something that's a prime, a 1, a 3, a 5, a prime number, then you can't reduce it anymore. Like I said, this could be way harder. In all the other years that I've taught chemistry, I've had to teach them the whole Percent to mass, mass to mole, divide by small, and then multiply to whole is the ROM that I've had to teach them. But you guys don't have to do that part. You literally have to be able to identify, is it an empirical formula or a molecular formula? And I got to make your test last weekend, so I know what's on it this time. That composition's a little bit more complicated.
Yeah, I have a question.
What?
Can we get exempt from the 6%?
Nope, not this year.
We did like the beginning of the year.
No, we did not this year.
Oh, we did.
We haven't had any exemptions this year. Not at all. No. We haven't. I've been here all year. We haven't had any exemptions this year. Present composition is how much of the element, normally or possibly the polyatomic ion, is present in a sample. I'm sorry, it's not my fault, I swear.
Who are you around? Like, come.
I don't know.
Is it really?
If it's more, it's a form piece. No, don't cough on each other. Okay, so
You go get tested and
It's-
tell us like positive.
yeah, I think you still have to have a certain time frame for that to pass to, I don't know, you know what, I don't even know what the rules are anymore.
But is it really like when it says positive right now?
I swear, percent composition is, now you're gonna have to use your periodic table once again. These things do not go away. It's the mass, in this case, it's the mass of the element divided by the entire compound. Hydrogen is 1.01. We're still doing 2 after the decimal. I'm sorry, Jared, don't do that. It's not my fault. Apologize if that makes you feel any better.
I don't think you can put it.
No, I don't think it is either. They were both a try. It was both a try. I'm sorry. Chlorine is 35.4. Did you get everything? That's not his cord down there, is it? Wait, is that y'all's down there on the ground? It's been here since last period. Okay, that's actually a second period. Cord. There it is. This is a Chromebook charger, isn't it? No, Dell computer charger. That's a personal Dell come back. What would be? No, I'm trying to figure out well, I mean, I'm not obviously gonna ruin anything. I'll figure it out. Well, I still have my phone charger from like 2 weeks ago, so. Anyways, you have each individual element. In this case, this is hydrochloric acid, hydrogen, 1 hydrogen for every 1 chlorine. When we add them together, the molar mass of hydrogen chloride or hydrochloric acid is 36.46 grams per mole. This part, most of you could do, no problem. You could. It's just each element times how many, and then you add them up. To do percent composition, you have the individual amount divided by the total. So 1.01 for each hydrogen divided by the total mass of hydrochloric acid, which is 36.46, times 100 is equal to 2.77%. It's really not hard. I mean, you're doing the same stuff that you did before using the periodic table. It's just how much of each element, or in the case of a polyatomic ion, of the ion is present in the compound. For the chlorine, it's the larger percentage. They should add up to a total of 100%. It's, what's my, what? Okay, you give me the ugly face, what?
So you take the original number from each element. And you
The
divide it by
mass?
Yeah, the mass.
Divided by the total compound. Yes.
You get that, you just-
It's each individual element divided by the total compound, which this part we've been doing for a while now.
I did find it was 36.46.
I'm sorry, what now?
Why did you find, multiply 36.46?
This just changes it from a decimal to a percentage. That's all. It's all it does, just changes it from a decimal to a percentage.
So what actual answer?
Well,
Is it those?
yes. Hydrogen is 2.77% of the entire compound. The chlorine is 97.23% of the entire compound. So how is this what? It shouldn't be.
So what I'm asking is like, did we just like round it?
It's not it could be.
Oh, we can make it a heck of a lot harder than it is right now, but they changed the teeth and they made it a heck of a lot easier on y'all.
That's not good.
Yes.
Oh, that's just funny.
Yes.
I know, she's like.
Yeah, this could be like way harder than it is right now. Okay. So we're gonna do the same thing for aluminum sulfate. There are 2 aluminums in aluminum sulfate. Each one is 26.98. There are 3 times 1 for the sulfur. There are 3 sulfurs. Each one is 32.07. And then 3 times 4 is a total of 12 oxygens. Each one is 16. I don't think I messed up any of my math. I did do that last week. I multiplied my numbers out wrong. Didn't do it on purpose. Now, when I add all of these together, I get 342.17 grams per mole.
Oh, is that what you're like 36.46?
Yes, I added everything together. Yes.
That's not gonna include.
And we've been doing molar mass now for a while. This, honestly, molar mass does not go away. It just doesn't. Now, this is the mass of the entire compound. I'm going to take each element's mass and divide it by the entire compound's mass to get its percent. You guys are writing this down. Let me check on mine here real quick. No, you can't. You have a hard time writing and listening. I got Lexi, Declan, and Veronica. Okay. You don't have the internet at home. That's no good. Oh, well. You want to get quarantined? Why?
Josh was no longer in season and I have nothing else to do.
Okay.
I'll check on my question. That's all.
That's a lot actually, because if I got community and
I do not want to have to deal with any of this quarantine stuff. Besides, I'll make my kid cry on camera again.
my dad wasn't.
This wasn't a period where a kid made my kid cry when she was quarantined and I had to teach from home.
Can I ask why you make the cry?
Because she wouldn't leave me alone. I was trying to teach students, and so I yelled at her and I said a bad word and she cried.
Yeah, when she got quarantined, I started like water text coming in there.
And I finally flip my stuff. Yes,
Snap, okay.
I did. All right, so each of these compounds divided by the total mass is going to times 100 to change it from a decimal to a percentage. And you still same thing, two numbers after the decimal is going to be its percent composition. So of the entire compound of aluminum sulfate, aluminum is just under 16%. The sulfur, oh, that's not exactly lined up straight. Oops. Okay, well, sorry. The sulfur is going to end up being 28%, because I'm doing two numbers after the decimal, and then the oxygen is the 56.11%. It's not hard. I mean, you have to take your time and you have to look up your masses of the periodic table. You have to calculate the total molar mass of the substance, whether it be an atom or ionic or molecular, I don't care. And then each element's mass divided by the total times 100 is its individual percent. Like I said, when they changed the teeth, they took something that would probably take a solid week and they turned it into one period's worth of information. And just in case, we do have a work day tomorrow. There were a couple of papers that if you did not turn them in, and this does include online, that the ones that were stapled, because you guys aren't normal or used to packets at this point, they need to be turned in today. Whether it be like in person turned in or digitally turned in.
Wait, how did you do
Let's
this?
see.
How do you do the other part?
How do I do which part?
Where you got the procedure? I already know how you got this one.
It's the individual elements mass, okay, divided by the compound's mass times 100.
Oh, okay.
That's it. It's really not hard. It's really not. And today's assignment's unbelievably short. But we'll still have a work day tomorrow to make sure everybody's on the same page. Oh, what am I doing? Oh, I'm making it go backwards. No, so we're going to go forward. There we go. Okay, now, the only thing I can ask you to do that's a little bit tricky is a percentage of a part of the whole, not just the element, but of the actual, in this case, carbon dioxide. How much carbon dioxide is present in sodium bicarbonate? Which I know you guys don't know how to name all these things properly yet, but we'll get there eventually. It's still partial divided by the total compound. So I'm going to do the total compound is 1 times sodium plus 1 times hydrogen plus 1 times carbon plus 3 times oxygen. The percent composition of the carbon dioxide in it would be 1 times carbon times, or not times, plus 2 times oxygen. Carbon dioxide's mass comes out to be 44.01. 12.01 plus 2 times 16 is 44.01. Carbon dioxide's mass. 12.01 carbon plus 2 times 16 adds up to 44.01 grams. You're giving me an ugly face again.
Yeah, man.
You are.
I didn't know what you was doing.
I got the mass of carbon dioxide from the periodic table. Carbon is 12.01,
Yeah.
oxygen is 16. 16 times 2 is 32, plus 12.01 is 44.01. You can check me if you want to. I don't care. I'm getting the mass of the carbon dioxide, not the sodium bicarbonate, which is going to be the bottom number. I want to know what the percent composition is of carbon dioxide in sodium bicarbonate. Now, carbon is still 12.01. Then the sodium bicarbonate, it's 3 times 16 plus 1.01 plus, if I'm remembering right, sodium is 22.99 if I'm remembering right off the top of my head. And when you add all those together, you get 84.0. All I did was just give you the masses. I just didn't work them out step by step like I did on the other slides. So when I do the mass of carbon dioxide divided by the mass of the sodium bicarbonate times 100, changing it to a percent, there's 52.39% of this compound in the form of carbon dioxide. I mean, y'all, this, like I said, this does not go away the rest of this year. It does not go away. Yes, it is the last one. So now, let me. I'm already starting to get a headache. It is darkened. Did anybody not pick up the assignment that is today's? It is really this simple today. You just have to use a periodic table. There is a back. Also, it's not just the front, it's the back. You have to be able to identify the masses of everything that is involved and just pay attention. Is it asking you for each individual element, like 1A and B? Or is it asking you specifically, what is the part of the whole, like this slide, for number 2 and number 3? The identifying, if it's empirical and molecular, is just on the back. Did anybody not pick up this paper mark from one? I'm sorry, what's that? I gotta see if I got any more slips for it. Is there anybody else that wanted the paper version? Okay. Y'all were all supposed to have turned in your bulletin by 4 o'clock on Friday. We did, and it was frustrating. We really wanted to do it. But let's not be worried. I promise. Let's see if I've got one of those papers. Today is the 8th. Is it the 8th? Yes. Yes. Learning lab also, yeah, hold on a second. I'll put more of these. Here's yours. And for those of you that are remote too, if you have any questions, you're more than welcome to ask. I guess that was the 8th, yes. Here's yours. Okay, you're welcome. Let me. I know some of your questions. Give me just a second. Let me stop the recording.